Have you ever looked up at the night sky and seen a tiny point of light moving steadily across the stars? It's not a plane, and it's not a shooting star. Chances are, you've just spotted a satellite. But what exactly are satellites, and how do these incredible machines stay up there, whizzing around our planet? Let's find out. First things first, what is a satellite? In the simplest terms, a satellite is any object that orbits or circles another object in space. So, technically, the Moon is a natural satellite of Earth because it orbits our planet. But when we talk about satellites today, we usually mean artificial satellites, machines built by humans and launched into space. Since the first one, Sputnik 1, was launched back in 1957, we've sent thousands of them into orbit. So, how do we get these massive, complex machines from the ground all the way into space? It all starts with a rocket. Satellites are packed into the top of a powerful rocket, which blasts off, fighting against Earth's gravity. As the rocket climbs higher and higher, it gets faster and faster. Once it reaches the right altitude and speed, it releases the satellite. Now for the really cool part. How does it stay up there without falling back down? It's a delicate dance between two forces, velocity and gravity. Imagine you throw a ball, it travels forward, but gravity pulls it down, and it eventually hits the ground. But what if you could throw that ball so fast that as it falls, the Earth's curved surface drops away underneath it at the same rate? That's exactly what happens to a satellite. Its incredible forward speed, or velocity, is perfectly balanced with the constant pull of Earth's gravity. It's essentially in a state of continuous free fall around our planet. It's falling, but it never hits the ground. Time for our first quiz question. What two forces keep a satellite in orbit? Keep that answer in mind. We'll check it at the end of the video. Now, let's take a peek inside a satellite. What are its essential parts? Think of it like a high-tech space robot. Every satellite needs a power source. Most satellites get their energy from the sun using large solar panels that look like wings. These panels soak up sunlight and convert it into electricity to power all the onboard systems. When the satellite passes into Earth's shadow, where there's no sunlight, it uses rechargeable batteries that were charged up by the solar panels earlier. The other crucial part is the antenna. A satellite is useless if it can't communicate with us here on Earth. It has antennas to both send and receive signals. These signals could be anything from your favorite TV show to GPS data or important scientific measurements. The satellite's body, called the bus, houses all the important stuff. The computer or brain that controls everything, scientific instruments, and the propulsion system with tiny rockets or thrusters that help it make small adjustments to its orbit. Speaking of instruments, what do all these satellites actually do up there? Well, they come in all shapes and sizes, each with a specific job. Let's look at the main types. First up, we have communication satellites. These are the ones that bring you live TV, long-distance phone calls, and internet access in remote areas. They act like giant mirrors in the sky. A signal is sent from a station on Earth up to the satellite, which then beams it back down to a different location on the planet. This allows us to communicate across vast oceans and continents almost instantly. Next, we have navigation satellites. Ever used a GPS on your phone or in your car to find your way? You have a network of navigation satellites to thank for that. The Global Positioning System, or GPS, is a constellation of about 30 satellites that are constantly sending out signals. Your phone's GPS receiver picks up signals from at least 4 of these satellites and uses them to calculate your exact location on Earth with amazing accuracy. Here's quiz question number 2 for you. What does GPS stand for? Think you know it. Our third type is weather satellites. These are our eyes in the sky for meteorology. They constantly monitor Earth's weather patterns, tracking clouds, measuring temperatures, and watching for the development of major storms like hurricanes and tornadoes. The images and data they collect are essential for weather forecasting, helping us prepare for bad weather and saving countless lives. Without them, your daily weather report would be a lot less accurate. And finally, we have scientific research satellites. These are the explorers of our solar system and beyond. Some point down towards Earth, studying our planet's oceans, ice caps, and forests to understand climate change. Others point outwards, into the cosmos. The Hubble Space Telescope, for example, is a famous scientific satellite that has given us breathtaking images of distant galaxies and nebulae, completely changing our understanding of the universe. The James Webb Space Telescope is its successor, peering even deeper into the history of the cosmos. Ready for the third and final quiz question. Which type of satellite helps us predict if you need an umbrella tomorrow? So, we have these amazing machines orbiting Earth, helping us communicate, navigate, watch the weather, and explore the universe. What does the future hold for satellites? The trend is towards smaller, cheaper, and more capable satellites. Companies are launching huge constellations of thousands of small satellites, called megaconstellations, to provide high-speed internet to every corner of the globe. Future satellites will also use AI to process data on their own, becoming even more efficient. We're also developing new ways to service satellites in orbit, like refueling them or repairing them, to extend their lifespan. However, this also brings challenges, like the growing problem of space debris, old, defunct satellites and rocket parts that pose a risk to active missions. Finding ways to clean up this space junk is a major priority for the future. Alright, our cosmic journey is coming to an end for today. Let's see how you did on the quiz. Question 1 was, what two forces keep a satellite in orbit? The answer is its forward velocity and Earth's gravity. Question 2. What does GPS stand for? It stands for Global Positioning System. And question 3. Which type of satellite helps us predict if you need an umbrella tomorrow? That would be a weather satellite. How many did you get right? Let me know in the comments below. The next time you look up at the night sky and see one of those moving stars, you'll know exactly what it is and the incredible science that keeps it flying. Thank you so much for watching. If you enjoyed this journey into space, don't forget to hit that like button, share this video with a fellow space enthusiast, and subscribe for more adventures into the world of science and technology. And hey, what should we explore next? Drop your suggestions in the comments, I'd love to hear them. See you in the next video.